Hi, everyone. Thank you for joining this session today. We'll be walking you through how API governance and API design have evolved over the years, and basically how we can make designing APIs and governing them smarter, more scalable, and more developer-friendly using open tooling. So a quick introduction. I'm Dakshitha. I'm working as a director of developer relations at WSO2. So in the past, I've been a software engineer, I've been a solutions architect, and I've also done a little bit of program management before I got into developer advocacy with a focus on API management, identity and access management, and integration. So I've been in the open source middleware industry for about 15 years. So Pubudu here will co-present. I'll let Pubudu introduce himself.
Hello there. I'm Pubudu Chinthaka. I'm the head of architecture for API management business unit at WSO2. I looked into the architecture of WSO2 API Manager, which is an fully open source API management solution. I'm also a committer and a PMC member of the Apache Stratos project. And I bring over a decade of experience into the open source middleware space. So that's about myself.
All right. So before I dive in, I'll just give you a quick introduction about our company. So WSO2, if you take a look at the open source API management offering, it's a 100% open source full lifecycle API management platform for building, integrating, securing, and exposing your enterprise digital services as managed APIs on the cloud, on-premise, and hybrid architectures. So yeah, so let's dive in. So APIs are innovation drivers and are no longer just glue code or mere connectors to your backend systems and data. So they are now core to how businesses scale, integrate, and innovate, right? So in fact, many modern products are polished APIs under the hood, and they're central to business strategy and not just implementation. So APIs are key to managing the complexity of exposing your business services and data, but we also have to manage these APIs well. Okay, so let's talk about the reality. You have dozens or hundreds of APIs built by different teams using different architectural styles with varying degrees of documentation, right? And that's where the sprawl becomes painful. How do we ensure consistency, security, and reuse for these APIs? So it's a problem, and it's still a hard problem. So the API lifecycle has become a critical pillar in modern software development. So especially in organizations managing tens to hundreds of APIs across teams, business units, or even partner ecosystems. So with this growth comes the challenge of consistency, quality, and governance. All right. So API management as a practice brings structure to this chaos. So if you take a look at this diagram, you can see that API management tools help organizations design, secure, monitor, and govern APIs across their lifecycle. And if you take traditional API management offerings, they focus on a few capabilities. So if you take a look at the API gateway box, so that's pretty much what fronts your backend services, which can be REST APIs, SOAP services, and any other kind of service. And the API gateway is used for routing, security enforcement, and protocol mediation. So basically, it fronts these backend APIs and services. And then you also have the API security components, which helps you protect the APIs with authentication, rate limiting, and threat detection, etc. Then at the same time, you need design and development tools. So you need to be able to build APIs and generate contracts, right? And then you will use the API lifecycle management components that help you version these APIs and be able to manage the different stages of the API lifecycle. Then you get developer portals and marketplaces for consumers to come and discover your APIs, and then they can subscribe to these APIs and consume them in a managed fashion. And you will have monitoring and analytics tools for tracking usage and performance. There are policy management and mediation components to apply quality of service, transformation, throttling, etc. And then you can also have ingress and egress governance that will help you control your incoming API traffic flow or your outgoing traffic flow, depending on your requirements. And then you can also look at API monetization, which helps you set up plans, usage tiers, and billing for the consumption of your APIs. So today, API management has evolved beyond these components with the needs of the ecosystem. So if you look at it, you can see multiple gateways over there. So it's not a single gateway scenario anymore. So you're looking at a centralized control plane managing many distributed gateways with gateway federation. And we're looking at gateways having to support diverse protocols like gRPC, GraphQL, and event-driven APIs. And then we are also looking at, we're looking at plugging these API artifacts into DevOps workflows, and then with command line interfaces, and we're also looking at observability, which has become a first-class concern. And with the rise of AI, we also need to manage the AI traffic or AI workloads with dedicated AI gateways. So let's just talk about the API lifecycle a bit. So APIs are products, and like any product, they go through a lifecycle. So the lifecycle starts at design. So you can define the shape, the contract, or the semantics of the API. Then the API flows through the implementation. You will figure out how to apply security and other quality of service policies. Then the API will go through deployment, where you expose the API via a gateway to various environments. It could be your dev environment, test, prod, and actually publishing the API after it is deployed to developer portals so that consumers can discover them. And eventually, these APIs will get deprecated once you get new versions of the API. And so each of these stages has its own challenges. But design and governance are often where inconsistencies creep in and scaling becomes quite difficult. So this is a quick mentioning of why design and governance are often the slowest, messiest parts of the life cycle. So design is messy because API definitions are often written manually or inconsistently. So there's back and forth interactions between front-end and back-end teams going back and forth about what the design should be and so on. And different teams have different interpretations of what good design, API design is. And then governance becomes slow because you have all these governance rules written somewhere, documented somewhere, but they're not checked until at the end. So reviews are manual or they're post facto. So teams either don't know the rules or find out too late. So these stages are painful because they've historically lacked automation, feedback loops, and good tooling. So this is what we're aiming to fix by combining open standards, open source tools, and AI to make design and governance more scalable, repeatable, or reusable, and developer friendly. Okay, so let's now zoom in on the design part of the life cycle, where it all begins and often where things go off track. So more and more organizations are adopting an API-first approach. So that means instead of building the backend first and documenting it later, teams start by designing the API, usually using a format like OpenAPI or async API, and getting feedback from internal teams, partners, or even consumers. So once approved, the spec becomes the source of truth. And that speeds up delivery and prevents surprises down the road. Okay, so now let's take a look at the tools that helps bring API first to life. So these are open standards that you can use: OpenAPI, Async API, GraphQL, gRPC, and other open standards to help teams communicate clearly and build interoperable APIs. So by using these machine-readable specs, you unlock tools that can validate, mock, and document, and also test APIs automatically, right? So let's just go through these specs, the specifications. So OpenAPI is a de facto standard for RESTful APIs. You can describe endpoints, you can describe parameters and schemas in a structured way. Async API extends this to event-driven systems, supporting protocols like WebSockets, SSE, which is server-sent events, Kafka, MQTT, and the list goes on. And there are alternatives like GraphQL that lets you consume or lets consumers query only what they need, which is great for front-end flexibility. And there's gRPC that uses protocol buffers for fast binary communication, which is ideal for internal microservices. Okay, so here's an OpenAPI snippet. I hope you can see that. So that's for a hotel booking API. So tools like WSO2 API Manager uses under the hood to power design, validation, and governance features. And OpenAPI is at the core of most REST API workflows today. And this is a very simplified example. So this defines a simple get rooms endpoint to list hotel rooms. And the response returns a list of room objects. And the component section defines a reusable schema for rooms. Okay, so async API is to event-driven APIs what OpenAPIs is to REST. So it's an open standards for defining asynchronous APIs. So think APIs that don't rely on the traditional request response pattern. So the idea here is instead of calling an API and waiting for a response, your services subscribe to events or publish data into streams. So use cases would be chat apps, IoT sensors, stock tickers, anything real time or loosely coupled. So this definition defines an event called room booked on the room/book channel. And other systems can subscribe to this event and react when a booking happens. And the payload includes details about the room and booking dates. Right, so if you use a tool like the API Manager, you can create an API from scratch, or you can provide, or you can import a specification. It could be an async API spec or an OpenAPI spec, a GraphQL spec. And the UI guides you through the process. And if you don't have a spec that you imported, you can create that the API from scratch, and you can generate a valid spec as you go. So here you can see the visual editor. You design your API. You can come up with your resources, and then you will see the resulting OpenAPI definition or the async API definition, depending on what you chose, if you started with a manual design. And once your spec, if it goes through, it can go through like an approval process. And if your spec is approved and the API is published, it can appear on the developer portals. And you can basically use the tooling to help generate backend stubs or SDKs. So this is how API first becomes real. All right, so let's discuss exposing your APIs for AI agent consumption. So one of the emerging use cases for well-structured APIs today is to enable machine-to-machine communications, especially with AI agents, right? But AI agents don't know how to consume a REST API out of the box. So they need metadata, descriptions, context. And they want to know what methods are available, what inputs they require, and what outputs to expect. So MCP, or the Model Context Protocol, changes that. So MCP is an open standard that gives AI agents a simple, standardized way to plug into tools, data, and services, no matter how they're built. And this slide shows you how you can build an MCP server from an existing API contract, or you can start from an existing API proxy. So you have various options. But yeah, so let's take a look at how you can use an API contract like OpenAPI. So here you can see how you can define MCP tools for the MCP server and map it to the resources in your OpenAPI definition. So what does this mean in practice? So it means you can make your APIs usable by AI agents without rewriting your backend. So you get a clean, governed layer where you decide what operations to expose to agents. So this is your OpenAPI based or service contract. So you can decide which of those resources are going to be exposed as MCP tools. So here you retain security rate limits and policies, whatever you applied earlier in the API management layer, that is going to be applied to your MCP server as well. And here you reduce friction in AI integrations by converting your OpenAPI spec into AI-compatible tools. So this is a great example of where design time investment in specs pays off, because your APIs are well described. You started with a contract. You can generate powerful secondary experiences like this MCP interface. All right, so contract first design gives us alignment and helps us reuse, right? But here's the catch. Writing these contracts manually from scratch is still hard. Okay, so this is a post on Reddit which says, why is writing OpenAPI YAML still such a pain in 2025? So I'm not sure, did one of you write it? Yeah? Okay. All right. I like the analogy where he says, or she, it feels like I'm playing Jenga with a blindfold. So this is one of those things I found on Reddit. And so what I would like to emphasize is, despite all the benefits of spec-first design, writing OpenAPI manually is still tedious. So you can mess up, as he says, indentation, you forget a required field, you change a schema and break something upstream. So yeah, so these are the problems that you may face. So what we're trying to say is, if you can get help with API spec generation using AI, that's one way to make it easier at the start, right? So you can use AI-powered API design assistance. So an AI assistant or AI assistants can basically be a chat-based API interface which can help you to generate REST, GraphQL, and async APIs using natural language. You basically describe what you want the API to be. And if you have UI visualization, then you can see like a structured view for easy understanding. And you can refine your prompt, or you can refine your request and basically refine the API to make it what you want it to be. So if you look at the business impact of it, you can speed up API design by reducing manual effort. You can get anyone, it can be someone who's non-technical, to create and refine these APIs. Okay, so here you can see how we do this using our open source API manager. So you can create an API from scratch by yourself. You can create one of those REST APIs, SOAP API, GraphQL, or else you can create an API with AI. So you can see in this second screen, you basically describe what you want. I'm sorry, I don't think that's visible, but you can, it says, I have an old system managing my product inventory, but it's outdated and needs to be modernized. I need an API that can efficiently handle products and their details, name, description, etc. So the assistant says, REST is suitable for managing product inventory with CRUD operations. If you need more flexible querying, consider GraphQL and so on. So you basically interact with the AI-powered API design assistant and come up with your API. And here you can see how this works in real time. For you to understand how this plays out, you basically get the first, the resulting API, and then you can refine it and get the API, work towards getting the API you need. And so that's pretty much how you can use AI to come up with your first specification. So with that, I'll hand over to Pubudu, who will show you how you can apply governance workflows and also make sure that the API contracts that you produce are basically aligned with the governance policies of your organization. So, yeah, Pubudu.
Thanks, Ducky. So far we discussed on how open standards and AI can bring API design faster and consistent, but the main idea is that without having proper processes in place, there are so many issues with the specifications, there are security issues, there are compliance issues likewise. So that's where the API governance come into the picture, where it will bring resiliency for the APIs, you can standardize APIs, you can have more reliable APIs in your API ecosystems. So let's dive in. Right. So if you look at API governance, so far, if you look at in your organizations, there are different practices that you follow. So due to these practices, you have different security issues. So for example, maybe some of your APIs are secured using basic code, some are with MTLS. Likewise, there is no place for you to govern all your APIs. Different teams follow different authentication options, different policies likewise. So due to these inconsistencies, there are various security issues, there are various compliance issues as well. And also there are manual processes that have been placed in the organizations to look at these different stages, and this also brings different inefficiencies and error-prone scenarios as well. And also on top of everything, there is very limited visibility for all these things around your API ecosystems. So those are the main challenges that we see around in API governance. So with having API governance in place, you can automate your policies, you can have standardized practices, you can have more insights into your system, how your APIs are doing, how your APIs are secured. So likewise, you can get more insights to what you are already having. And also on top of those, you can have approval workflows as well, which will help you to understand how basically approval can be placed as well, and make sure APIs are starting from design to promote, everything is followed in a different stages of the life cycle. Right, so if you look at the business impact, with having API governance in place, you can reduce the overhead, which will help the organization to ensure security, compliance, and also bring the credibility as well. And also having enhanced visibility and control, you basically make sure your organization is having a more visibility and more control to all your APIs. Right, so when it comes to API governance, I have taken two specific policy as code tools here. So the Spectral is one of the tools that you can use for design time governance. So using Spectral, which is a linter, you can use linting for all your open APIs, async APIs, even JSON and YAML schemas as well. So this brings more flexibility by having you to define your rules in a way that you want to have for different use cases. And also you can plug this tool in your CI/CD pipelines as well. On the other hand, you have the OPA, which is an open policy agent, which focus more towards the runtime policy enforcement. This uses Rego-based policy language where you can define different policies based on your requirements. And then this is also, again, you can apply in a centralized manner where you define these policies and deploy with your API gateway and enforce security. And also this is heavily used in a cloud native environments with Envoy proxy, Kubernetes, Terraforms, likewise more cloud native level accesses here. Right, so let's look at how Spectral as a linter can bring value to your specification. So the main idea is to catch design issues early and validate against best practices and improve the consistency across the teams. So in here basically the UI shows that as the admin portal, that's where the administrators come and do all the administration stuff. So here you can define different linting rules. So the linting rules can be, for example, in this case, you have to have an email address for your OpenAPI so that the others can contact you. Likewise, you can define different rules as well. So then the idea is that once you have the specification, the linter will provide you the results where you can have more understanding how your specification is doing, what are the violations, and as a developer you can improve these and you can basically resolve all these issues. So this is how you design and you basically take open tooling into consideration and get help from the tooling to improve your design. So but API is not just about the open API or the specification async API. So API is having more resources, like there are so many stuff around an API. So I have this API project which consists all the required information. So it has API YAML which defines some of the metadata that is required for an API. So then you have the different policies. Policies can be, you have different header-based routing policies, payload modifications. Payloads can be JSON to XML. Likewise, you can have different policies. So all this information have to be there to define an API. And also you have API documentation as well, which will help others to understand how to utilize your API likewise. And then also you have the certificates which will be your backend certificates or MTLS certificates likewise. So the main idea is that the Spectral can be extended not just for the linting but also to have other various policy rules as well. So in this case, I have defined a role using Spectral where to validate whether my API is having secured all the resources. So this will check whether all my resources are secured and having different authentication options likewise. So likewise, you can define different roles and make sure you just not checked on the OpenAPI specification, but also you looked at other artifacts in an API as well. So if I talk about more into the concepts of governance, so the key element is the rule set. So that's what I discussed earlier with Spectral, where you can define different rules. So here the main idea is that I have two rule sets. So the rule set one is more about API best practices. So that's where you can define your API guideline where how you define your API, what are the standards that you have to follow. Likewise, so here I have two rules as the API have to be below 50 characters. The versions have to start with V likewise, and then you have the second set of rules set which can be based on your vertical. For a finance, it can be whether your APIs have to be secured always, then you have to have standardized error responses likewise. So the likewise you can define different rules, and then the main idea is that you can combine these rules and create a policy. So the policy consists different rules coming from different angles, and then you can apply these policies to your APIs or maybe some set of APIs that you have in the system. And the other thing is that you can enforce these policies at the API creation, API update, even when you are trying to deploy your API into a gateway or when you are trying to promote your API into a developer portal for external consumptions. So likewise, you can define how you engage these policies. And as you can see at the bottom, where you can have a label for your API. Once the label matches with your policy, you can basically apply these different governance policies and make sure your APIs are adhering to these governance rules. So going towards the dashboard aspect, where this will help you to understand how your APIs are doing. So I have two windows where one window is mainly targeting the administrators, which will help the administrators to identify what are the APIs and how they are secured and what are the violations in the API ecosystem likewise. Then on the other hand, we have a different portal which will help the API developer to understand what are the errors, what it needs to be done to improve these errors and the violations. So likewise, this will give you more visibility into the errors and make you understand what needs to be done in order to resolve all these issues. So coming back to OPA, Open Policy Agent, so similar to the Spectral, you can do the similar stuff using OPA as well, where you can define policies, you can then use these policies in your governance ecosystem and plug as similar to what I explained in using Spectral. So the likewise you can utilize this OPA as well. So the only difference here is that the implementation earlier it was Spectral, but now with OPA you can basically implement the similar scenario and have a more end-to-end API ecosystem with the governance. Right. So let's look at how we can bring AI into the API governance as well. So if you look at today, your organizations are having best practices, guidelines, maybe most of them are in English, or maybe you have native language based documents which talks about your best practices, which talks about how you have to be like maybe it can be your security guidelines likewise. I know probably when you start something you looked at these guidelines, but with time you never looked at these documents, even you don't touch those, right? So the main idea is to bring, what if we can bring these documents into the system and the system can validate those rules, those best practices that are there in the documents against your APIs that you have defined. So in our solution, we have looked at bringing these English documents or whatever the documents that are there as PDF documents, and then we basically create governance ecosystem to apply those rules that are there in the documents to APIs. So this will give a similar idea where you can still look at how your APIs are doing, what are the violations, what are the issues. Likewise, you can get a similar idea. So we can basically utilize AI in this case as well to basically improve the overall experience. Right. So let's look at now. Probably you will start with a portal where you design everything, but now CI/CD is one of the aspects you looked into when you do develop different APIs and the different implementations. So maybe developer will start the OpenAPI specification, and then on top of that it will bring the API YAMLs or the documents or the certificates, and it has this API project which consists all the relevant information related to the API. And then on top of that you have environment related information. For example, in the dev environment you have a different endpoint, you have a different credential. Likewise, when you compare that to a production environment, so likewise you can have an environment configuration in there, and then what you will do is you commit your API project and also your environment configuration into a repository, and then this will trigger a CI/CD pipeline. And the first thing it has to validate here is that whether your API is aligning with the API governance policies that have been defined in the your organization. So it will validate that. Once the validations are passed, it will deploy to your development environment. Maybe this can be your lowest environment. Then on top of this development environment, you can run certain tests, you can validate the functionality of the API, and then you can promote your API into a higher stage like QA, production, or any other environments that you want to promote. So this is the typical CI/CD flow we have, and on top of that we have API governance validations to make sure you align your API best practices and the adherence to your policies that are there in the organization. Right. So if you look at AI is not just limited to design and governance, it spans across the entire life cycle of API. So with AI now you can use API testing, where when you provide your requirement in natural language, it can execute these test cases and generate responses for you. And also developer portal is one of the aspects. That's where the application developers come and discover the APIs. So here, as an application developer, he can provide his scenario, and the AI will be able to provide the relevant APIs that it needs to be used in that use cases. And also the theming is one of the aspects in the developer portal. Once you provide your organization domain, AI can help you to look at the organization's website and grab the styles that you have, grab the fonts that you have, and look at your CSS and apply the same for your developer portal as well. So these features will help you to improve your efficiency, improve your way to go into the market likewise. And also the SDK generation will help you to understand, once you provide your use case scenario, it will generate AI based code generation which you can use in your specifications and your application development. Right, so let's look at some of the key takeaways from our session today. So we looked at starting from API first strategy, where you can define your OpenAPI specifications, and on top of that you can use linting and API governance to help you make sure that your specification and your APIs are adherent to the standards that have been there in the organizations. And also you can use AI in different stages of the API lifecycle and improve your API designing, and you can improve the governance, automation, and even you can also extend that to observability aspects as well. So I think that's what we wanted to cover today. So any questions? I think we can take questions. All right, then thank you very much for your time.